So let's solve this numericals. Here I have taken time quantum as 3 seconds. Okay, and you see there are lots of processes are there: P1, P2, P3, P4, P5, P6. But don't worry, it will not take much longer. And the arrival times are 5, 4, 3, 1, 2, 6. Burst times are 5, 6, 7, 9, 2, 3. Okay. Now let's solve this numericals. So here time quantum is 3 seconds. Okay, here be careful. Here don't start with process P1. Don't just blindly start with process P1, because you see P1 has not arrived earlier, although its process ID is 1, but it doesn't mean that it has arrived earlier, because here it is specifically mentioned that P1 is not arrived earlier. If you see the arrival time of P1, it's 5 seconds. So which process has arrived earlier? P4. So start with P4. So just here be careful. Okay. Now we'll draw the Gantt chart here. Here is it visible? Okay. Okay, fine. So you see P4 has arrived at 1 second. So at 0 second, none of the processes are there. So from 0 to 1, we have nothing. Okay. Now at P is equal to 1, you see P4 arrived. So here I will write P4. P4. So P4 will run for how many seconds? 3 seconds, because time quantum is 3. So P4 will run for 3 seconds. So 1 plus 3 is equal to 4. How many seconds left for P4? 9 minus 3, 6 seconds left. Okay. Now you see within these 4 seconds, how many processes have arrived? P4 is already there. P4 is already there. Okay. And how many processes are there within these 4 seconds? In second P5 came. In third second P3 came. And in fourth second P2 came. So processes available till here is all these processes. So now the time quantum, since the time quantum has expired, so P4 will be removed from here and P4 will come and sit here. Fine. Now CPU will be given to P5. So here I will write P5. So you can see here the burst time for P5 is only 2 seconds. It means what? Less than time quantum. So P5 will fully execute for 2 seconds. No need to execute for 3 seconds, because the burst time is only 2 seconds. So 4 plus 2, 6. So P5, since P5 has fully executed, so it will be 0. It means what? P5 is done. The task of P5 is over. So completely remove P5. Fine. And you can also see that yes, just wait. Yes, and you can also see that within these 4 to 6 seconds, 2 processes came. You see P1 arrival time is 5 and P6 arrival time is 6. So here I will write P1 and P6. Okay. Okay. So now after P5, CPU will be given to P3. After P5, CPU will be given to P3. So here I will write P3. So Burst time of P3 is 7 seconds, but it will run for only 3 seconds because time quantum is 3. So 6 plus 3, 9. So here, how many seconds left? 4 seconds left. 7 minus 3, 4. Since P3 task is not over, so here from I will remove P3 from here, and P3 will come and sit here. Fine. Now, after P3, P2 is there. You just see P2 is there. So CPU will be given to P2. Here I will write P2. P2 will run for the time quantum for 3 seconds. So 9 plus 3, 12. Okay. And 6 minus 3, 3. 3 seconds left for P2. So still P2 is left. So I will cut P2 from here and P2 will sit here. Fine. So now CPU will be given to P4 again. So how much time left for P4? 6 seconds left. So P4 will run for 3 seconds. 12 plus 3, 15. And here how much time left for P4? 3 seconds left, because 6 was left. 6 minus 3, 3. So still P4 is left. So here I will remove P4 and P4 will come and sit here. Okay. Now CPU will be given to P1. And you see the burst time of P1 is 5 seconds. Okay. But P1 will run for 3 seconds. So here I will write P1 and it will run from 15 to 18 seconds. So how much time left for P1 here? 5 minus 3, 2. Fine. So still P1 is left. So I will remove P1 from here and I will write P1 here. You have to be very careful while solving this. So after P1, P6 is there. So you see the burst time of P6 is 3 seconds. Okay, so P6 will run for 3 seconds. It means what? Since the burst time is equal to time quantum, so P6 will fully execute. P6 will fully execute. 0 seconds left. It means what? P3 is done. So I will remove P6 is done. So I will remove P6. So P6 is done. Now CPU will be given to P3. So here is P3. So I will write P3 here. So 4 seconds are left, but it will run for 3 seconds. So 21 plus 3, 24. So how much time is left for P3? 4 minus 3, 1 second. So still P3 is remaining. So I will remove P3 from here and I will write P3 here. Okay. Now it's P2's turn. So 3 seconds is left for P2. So P2 will fully execute because time quantum is also 3. So here I will write P2. 24 plus 3, 27. So now P2 is done. P2 is fully completed. So here 0 seconds. So only 3 processes are left: P4, P1 and P3. Now it's P4's turn. Now P4 has only 3 seconds left. So P4 will fully execute for 3 seconds because time quantum is 3. Here 27 plus 3, 30. Now P4 is fully completed. Here it will become 0. Now P1 is left. 2 seconds are left, but the time quantum is 3. Since the burst time is less than the time quantum, so the process will execute till its completion. So here I will write P1 and it will run for 2 seconds. Okay. So now P1 is done. After that, you see only one process, P3 is left, which is 1 second. So here I will write P3 and it will run till 1 second. So P3 is done. So you just see how the calculations are being done. It's very important. because during the examination times the mind is totally tensed. We are totally tense. So even if we do even a single mistake, even a minor mistake will lead to you in a big trouble. Okay, so just practice these types of numericals as much as you can, because in the examination times, even after even after solving lots of questions, there are some chances of doing calculation mistake. Okay, so you need to be sure that, okay, I will not do any calculation mistake, because these questions are easy and these questions carry generally 2 marks. Okay, so if you will solve if you make some mistakes in these questions, then you will lag behind, because this question is easy for rest of the students. Rest of the students will easily solve this question, and they may get better rank than you. Okay, so don't try to make any mistakes in easy questions. Okay, now let's calculate the completion time, turnaround time, burst time, completion time. I think you can calculate this part. And also one thing is there, while I am solving the numericals, you just also cross check your solution with my solution, because because there may be some calculation mistake. That's why I'm telling. Just don't blindly copy my solution. Okay. So let's calculate let's see the completion time. Completion time of P1 is 32. You see from here, it's 32. So here I will write 32. For P2 it will be 27. For P3 it will be 33. For P4 it will be 30. For P5 it's 6. Yes. And for P6 it will be 21. So here I have written the calculation completion time. Now the turnaround time is what? Completion time minus arrival time. So turnaround time for P1 32 minus 5 27. For P2 27 minus 4 23. For P3 33 minus 3 30. For P4 30 minus 1 29. For P5 6 minus 2 4. For P6 21 minus 6 15. So in the same way we can calculate the waiting time. So what's the waiting time? Turnaround time minus burst time. So what's the burst time? Yes. So what it was here? What I had written, is it 27? No, it's 22. So for P1, turnaround time is completion time minus arrival time. No, it's 27. 27. Yes. Now just write down the waiting time. Turnaround time minus burst time. 27 minus 5, 22. Then 23 minus 6. 23 minus 6 what? 17. Then 30 minus 7. 23. 29 minus 9. 20. 4 minus 2. 2. 15 minus 3. 12. So we have calculated the waiting time, and also we can calculate response time here also. They have never asked response time till now. I have never seen any question, but okay, it's better to solve, because there's it's very easy to find out the response time. So you see how to calculate the response time of P1. P1 arrived at 5, okay, but P1 got the first response at P1 at 15. Arrived at 5, but P1 got CPU first time at 15. So what's the response time of P1? 15 minus 5, 10. Fine. Now P2 arrived at 4. But when the first time P2 got the CPU, just check from this side now. While calculating the completion time, you should check from this side. But while calculating the response time, you should check from this side. Okay. Just use your intuition. Okay. Here is nothing new. Here is nothing to tell you. So yes, let's calculate the response time of P2. P2 arrived at 4 and P2, yes, P2 got CPU at 9. So response time is 9 minus 4, 5. Okay. Now P3 arrived at 3 and got chance at 6. 6 minus 3, 3. Now P4. P4 arrived at 1 and immediately it got the CPU. It means what? It's started responding immediately. 1 minus 1 is equal to 0. Then P5. P5 arrived at 2 and got response at 4. It means what? Response time is 4 minus 2, 2. And then P6. P6 arrived at 6, but it got first response at, it means what? It got first CPU at 18. 18 minus 6, 12. So in this way you can solve. Okay.